In this video, I will introduce a way to construct and destruct any reflected type at runtime. This can allow us to manage instances of types without needing to know the actual type at compile time. We use this to create typeless containers such as typeless unique pointers, typeless tuples, and typeless vectors. Let's take a look on how to implement this in the reflection system. So in our type information structure, we will store 5 more function pointers. The first one, constructor, is a function pointer that will construct a register type at the location of the given address. The second and third ones, copy constructor and move constructor, will construct the type at the location of the address while taking the address of another instance of that type to copy or move it. The destructor function pointer destructs the type at the given address, and lastly, the swap function will swap the two instances of a type. In this section, we set the values of the function pointers. To fill in the constructors, we use the placement new operator and some static casting to construct the instance on the location of the given address. The destructor pointer will static cast the void address into the type and then call the destructor on it. The swap will just call std swap on the two addresses that are interpreted to be the type. These enable booleans that we can see here are compile time boolean values. By default, they just check if the respective operation is possible or not, but they can be overwritten whenever the developer wants or needs to using these macros right here. If we go back to the setters, we use a const expression if to check at compile time if the section should be compiled or ignored. Let's now use these function pointers to show how to instantiate a type at runtime. This is a custom class called verbose class. It will print to the console whenever the type is constructed or destructed. We will use this class for checking whenever it is created or destroyed inside of the demo. In the first demo, we will construct, modify, and destruct a type using only the reflection info registered in the reflection system. First, we get the reflection info, then we allocate memory for the type. After that, we use the construction function pointer in the reflection system to construct the type in the allocated memory. Then we make sure it's initialized before we modify the instance. Here you can see it was modified correctly. Finally, we destroy the type using the destruction function pointer before the memory gets released again. In the second demo, we will construct two instances of a type. The first one is constructed normally and then modified. Then the second one is constructed using the copy constructor. Here we check if it was copied correctly. Then we check the values before doing a swap using the swap function pointer in the reflection system. And then we check the values again and notice that the values were swapped. Then lastly, we destruct the type before freeing it. In the last demo, we will take 10 random types registered inside of the reflection system, construct them and serialize them to the console. Keep in mind that these types could have been registered anywhere inside of the program, which is what makes the reflection system very modular and attractive to use in big programs. Thank you for watching the video. Next video we will create some helper types that will manage the construction and destruction of types and their memory, just like we did in this video. So please check out the Glassify library at GitHub. The link can be found inside of the description. See ya.